Next thing we're going to look at is two-step equations. So let's see if you can follow the pattern. A one-step equation took one step to complete. So a two-step equation is going to take, anyone? Yes, you in the front row. That's right, 2 steps to complete. Now, there might be little things in there that we don't really count as steps that you want to do to get things in a little bit easier order for you, but this is the basic idea, and you're going to be doing all the same stuff you were doing in the one-step equations, only going to be doing 2 of them to get to the final product. All right, hang on, here we go. So here we have the equation 2x plus 3 equals 13, and it's important to remember that this is not some mysterious thing. All this is saying is there's some number, we haven't figured out what it is yet, that if you multiply it by 2 and then add 3, you're going to get 13. Now, if you had some answer choices, you could just try them out. Or really, this one's simple enough that you could just try out numbers and see which one works. Now, once the numbers start getting a little more complicated, that's not going to be a good approach. So please, no complaining about why do I have to do all these steps when it's obvious what the answer is. So, first thing we want to do is we want to get rid of everything that is not directly connected to the x. And I'll have an analogy in a minute. Maybe will help you remember what order you want to do things in. So what I want to do is deal with this first. Okay, we're kind of going from the outside, the furthest away from the x to the x. So I'm going to get rid of the 3. And then I'll have nothing but an x term over here, and then I want to get rid of any numbers that are connected to the x, in this case a 2. Okay, so it looks like this. First thing I want to do, get rid of the 3. The way I can do that, well, 3 is being added, so we want to think opposites. If 3 is being added, we want to take it back away again, but of course you have to do that to both sides just like we did in one-step equations. So this bit's going to go away, and some teachers actually teach to go ahead and physically cross that out. And so all you're left with on this side is 2x, and I'll write that down. I'll put it under where it was before. And 13 minus 3 is simply 10. All right, now I move things up just a little bit so we'd have a little more room. Again, 2x equals 10 is just like one that you've done in the one step at this point, one-step equation. So this 2x means 2 times x. The opposite of multiplying x by 2 is dividing x by 2. I believe if you're using IXL, they'll actually write the divided by 2 off to the right. What we're going to do is write it like a fraction. We're going to immediately do it on both sides. Remember, a fraction is just a division problem. It's another way of thinking about division, so we can write it this way, and that just makes it easy to cross off, to cancel out those things that match on the top and the bottom. So if we multiply x by 2 and then divide it by 2, what's going to be left? X. And if we take 10 and divide it by 2, why, that's just 5. All right, so here is the analogy I promised, and I know you've been on the edge of your seat waiting for it. When we solve this, I sort of ask you to take on faith that we need to deal with the addition first, and then after we subtracted 3 to undo the plus 3, that we would then deal with the 2 that's being multiplied by the x. Okay, well, this isn't really an explanation. Like I said, it's really more of an analogy. And I'm trying to leave enough room here. This program has some weird quirks that make it a little bit challenging to work with. One of those is it's hard to erase things. All right. So I'm going to think of this as following the order of operations like we're packing a suitcase. So the first thing we do when we're trying to figure out, well, what does 2 times 5 plus 3 equal? The first thing we're going to do is multiply. Now don't worry that some of the letters are sticking out below the bottom of the suitcase. I'll just get another one after we finish this. The second thing we do, according to operations, order of operations, is we add. So we are following the order of operations to pack our suitcase. Well, when you unpack, let's say you put your shirts on the bottom and then you packed pants on top of that. Hopefully when you unpack, you're not digging through down to the bottom and unpacking the shirts first and then dealing with the now wadded up pants that you have completely ruined trying to get to the bottom of the suitcase. No, you're going to do it in the opposite order you packed it. You're going to take the top layer out first, which in this case is addition. And since we're unpacking, we're going to unpack the 3, and we're going to do that. We're unpacking the addition by subtracting. Okay, now once the addition is unpacked, the only other thing we have in this particular suitcase is multiply. The unpacking version of multiply is divide. So we just do that second. And surprise, surprise, x still equals 5. See, I'm out of room here. X still equals 5, just like it did when we solved it originally. So keep this analogy in mind of packing and unpacking, because when these get to multi-step equations that have a little bit more than 2 or 3 steps, this is going to make it clear what you're supposed to do. All right, we're going to do another one, and the only difference here is everything's kind of flip-flopped. Your x and all that business is over here on the right, and the 9 is over here. Now, there's no reason you can't just do this exactly the same way. But remember, equals means that both sides are balanced. So we could always just flip them if that makes you more comfortable. You could write it like this and then solve it if you just like having it with all the busy stuff on the left and just the plain old number sitting over there on the right. It doesn't really matter. But since I got to pick one way, I'll go ahead and go with this. And now we're just back to doing the exact same steps we did before. Go ahead and pause the video, work it out, and then unpause it. I don't know what happens to me when it's paused. Am I in some sort of suspended state? Am I even conscious? These are questions that are much too large for me to answer in this video. But go ahead and pause it. And now you're back. Welcome back, if you actually did pause it. All right. Why am I adding 11 to both sides? Well, of course, because 11 was being subtracted from 5x, and I want to get that x all over there by itself. So the first step is to get rid of the things that are further away from x. So we're going to deal with the just plain constant here first, because if you take away 11 and you give 11 back, you're right back where you started from, in this case at 5x. And 9 plus 11 is somewhere around 20. The second step, 5 is being multiplied times x, so we're going to divide by 5 on both sides. 5 on the top and a 5 on the bottom cancel. That's only because we're doing the opposite of multiplication. If this was 5 plus x, you could not cancel like that. It's only when everything's being multiplied on the top and bottom you can cancel out the things that are the same. 20 over 5, that's just another way of saying 20 divided by 5, which is and always will be 4. Here's another one that is similar, but we've got our x term here close to the equal sign. We've got the 5 over here. Well, remember, we are in the land of the commutative property. So again, if you want, you can simply rewrite this with these two terms switched, just so it looks more like what you're used to. But I do want to show you that you don't have to do that, so I magically made it go away. We're still going to follow the same logic. The thing that's furthest away from the x term here, we're going to get rid of first. It's being added to 6x. It's positive. It doesn't have a plus sign in front of it, but it's positive. And so I'm just going to subtract it away. But of course, I'm going to subtract it away from both sides to keep it nice and even. So plus 5 minus 5, that just goes to 0. That leaves us with a 6x on this side, and then 29 minus 5 is 24. And the next step, of course, is to divide. 6 divided by 6 is just 1. So 1 times x is just x. Getting ahead of myself, I got to divide both sides by 6. 24 divided by 6 is 4. So x equals 4. And again, we can pop it back in for the x up here just to make sure it works. 6 times 4 is 24, plus 5 is 29. Must be the right answer. Here's one that looks maybe a little scarier. We have x over 4, so it's now involved in a fraction. Plus 9 equals 14. So First of all, let's remember a fraction is just a division problem. If you ever wanted to convert a fraction to a decimal, or let's say you had an improper fraction that was bigger on top than on the bottom, the way you handle both those things, you divide the top by the bottom. So the division bar is what we can call the fraction bar, and then it becomes a division problem. So the reason I mention that is the opposite of division is multiplication. Before we can do that, though, we've got to get rid of the 9. It's being added, so I'm going to subtract it from both sides. And I'm going to get x over 4 equals 5. Now, the next thing we want to do is, well, I'm going to make a little space first. So your eyes are not deceiving you. Everything got a little bit smaller. I was just running out of space. I actually lost track of what I was doing, so I'm back with us. All right, let's think of x divided by 4. Let's think of this part as being x divided by 4. Well, what's the opposite of being divided by 4? Well, multiplied by 4. So I'll try to make room for this here. And what's wrong with this? Take a second to figure it out. Yep, I didn't do it times 4 on both sides, so now I have. When we multiply fractions, whole numbers, we usually put a 1 on the bottom, but what you'll get used to very, very quickly is if there's a 4 on the bottom and I'm multiplying by 4, it's x divided by 4 multiplied by 4. And then there's just a 1 on the bottom. Well, x over 1 is just x. So somewhere, let me figure this out. Let's move all of this over. I will rewrite this. The only thing we have left on the left side is an x. Let me just put a line here. And on the right, 5 times 4 is 20. So anytime you've got something on the bottom of a fraction, you can just multiply it by something on the top of a fraction, in this case just on top of 1, and those cancel out. Of course, the easy way to think about it, x divided by 4 times 4. If you divide something by 4 and then multiply it by 4, you're right back where you started. I don't know, at this point you may want to start doing the exercises on IXL. They do give you some explanation. If you miss one, they may not sort of notate everything the exact same way. I think, for example, that if they're doing something like this, I'm going to leave just a little bit of space, they're going to do it off to the side rather than down below, which is fine. But I'm going to keep doing it the way I'm doing it because that's the way I like it. But one thing I wanted to show you, and I don't know if this will show up in the IXL exercise where you are right now, and again, this is only if you're at the Martha O'Brien Adult Education classes. We use these videos and we use IXL for our practice. But let's say we had something like, I don't know, let's say 15. Okay, I should have had the problem there before. What I want to show you is that sometimes you get weird fractions as answers, and unless the problem tells you differently, you can just leave it as a weird fraction. In fact, when you're solving algebra problems, a lot of times you don't even need to turn an improper fraction into a mixed fraction or anything like that. So let me show you what I mean. Again, we're going to solve this the same way we have been. 3x on the left, 13 on the right. Now I'm going to divide both sides by 3. Well, what is 13 over 3? It's not anything. If you divide 13 by 3 on a calculator, you're going to get what? 4.3333. If you turn it into an improper fraction, it'll be 4 1/3. But unless the problem calls for you to do any of those things, you can just leave it in this form right here. And sometimes that can just make things a little nicer. You just don't have to worry about converting it to a different form. Here's one more example. I've seen a few of these on IXL where the x term is the second term, and this can create a little confusion. Well, especially when it's minus the x term. In this case, 15 minus 3x equals 9. I'm going to run through do this two ways. I don't like to give choices typically, but I like to show one way, and then eventually you may figure out other ways. It's all the same math, it's just different ways of thinking about it. One way to do this is simply exactly like we've been doing all of them. Just because the 15 is in front doesn't mean anything is going to be different. All I'm going to do is subtract 15 from both sides, and everything that comes after the 15 is going to stay exactly the same. 15 minus 15 is 0, so obviously that's not going to do anything but disappear. And then 9 minus 15 is negative 6. And then the second step, what's in front of that x? What's being multiplied by x? A negative 3. So we just divide both sides by negative 3. On the high set, you can use a calculator. I highly recommend that you get real familiar with how to add, subtract, multiply, and divide integers. It'll speed things up for you. And it's really easy on the cheap calculators that we use for the high set to kind of screw up just entering negative numbers. The way you do it's kind of awesome, awkward. Okay, so negative 3 cancels out with negative 3. Negative 6 divided by negative 3 equals positive 2. So here's another way to think about this problem, and this is really more in line of thinking about either simplifying complicated expressions where there's a lot of numbers and different terms with x in them, and they're positive and negative, and you got to combine them all. And it's also helpful for solving multi-step equations, which are going to come up here in just a minute. And the idea that I'm trying to get at is this. This says 15 minus 3x. Minus means we're going to subtract. I have said subtraction is not commutative. You can do 3 plus 5 is the same as 5 plus 3, but 3 minus 5 is not the same as 5 minus 3. And yet, I can rewrite this and just for a problem like this, you might want to do it just to make it look like what you're used to with x first. But the main idea here is that the minus sign all of a sudden becomes the negative sign in front of the 3x. Why are we allowed to do that? And the reason we're allowed to do that is because 15 minus what? Well, minus 3. Well, is it minus negative 3? Nope, that's not what it says. So minus positive 3x equals 9. The way you do subtraction with integers is that you change it to an addition problem, and then you change the sign of the second term. So I have changed this from 15 minus positive 3x to 15 plus negative 3x. And that allows me then to take this entire term, negative 3x, and put it wherever I want, because these things are being added. So we just use a commutative property. So when we solve this, we're going to solve it basically the same way you're used to. So now that we've rearranged it, the only real advantage in this small two-step equation is it kind of looks like what you're used to. But like I said, when you get equations with a lot more terms, you got to combine them. There's some negative numbers with x, there's some positive numbers with x, and you got to put them all together. And there's some subtracting going on. It can get confusing, so you want to be real comfortable with the idea that something like 15 minus 3x can be rewritten as negative 3x plus 15. So basically, the minus sign stays with the term. We treat it like everything's being added, and then the minus sign becomes a negative sign in front of the number. I hope that's clear enough. If not, you'll get the hang of it soon. First, we want to get rid of the 15 like we did the other time. That leaves a negative 3x. That is a negative 6. And then once again, we just divide by negative 3. So it really didn't change our procedure very much. All it changed was the order things were in. And if that makes things easier for you, you can do it this way.